Hello, everybody, and welcome to today's lesson in geometry. I know you are very excited that you still get to hear my voice today, even though I am not in school. So, there will be a few things we're going to talk about today. Hopefully, you guys had an okay MACT activity today, and your proof packets are all turned in as well. But today, the proofs do not necessarily go away. We just look at different proofs today. So, as you are looking at your note sheet, please notice that there are two different theorems today that you are going to be looking at and using eventually in your proofs. So the first one is called the alternate interior angles theorem. Hopefully that rings a bell. Alternate interior angles are when you have two parallel lines and a transversal that goes through them. This is saying that alternate interior angles, that angle and that angle, are congruent to one another. Okay. The second theorem is talking about corresponding angles. And as you're reading through that, you will see that you still are dealing with your two parallel lines followed by your transversal. Corresponding angles are in the same spot in your group of four angles. So this is some identifying between parallel lines and your transversals. Please pause the video to write down both of these definitions. Now, what we're going to be looking at with each one of these is these two theorems are going to actually come up in proofs as you are doing them tomorrow when I get back. And you'll notice that the pictures that you have for 1 and 2 are going to be partly overlapping, and we need to look at what information is given to us, just like we always do for a proof. So for number 1, it says we're trying to ultimately prove that PQS, triangle PQS, and triangle RSQ are the exact same. This notation in the given between your PS and your QR is your two vertical lines. It's your parallel lines. So what we do know is that PS here is parallel to our QR. We notate that with our two arrows that actually say that they're parallel. And we're trying to make this picture look like one of the two pictures that we created on the top of our note sheet. So by us doing that, we can accurately draw in, different color if you would like to, your transversal into this picture. The nice part now is you may have to turn your paper a little bit, but we have one of the two situations. We have alternate interior angles, and there's actually two options. You could say that this angle, which is angle PSQ, is congruent to its other angle on the inside in your other triangle, in your bottom triangle. That is angle RQS. Those two angles you know are congruent because of alternate interior angles. So your AIT. Okay. If you want to write alternate interior, you can write that down as well. Either one of those two would be acceptable. Okay, so now as you're looking at the second one, the picture's a little bit different. Notice how in number 1 there was some overlap between these two triangles. For number 2, they're stacked or they're on top of one another. Okay, but we always start with our given. We have the two triangles to the right, and again, we have a couple parallel pieces of information. You have XZ and WL that you know are parallel, not congruent, but parallel. So now we're trying to figure out where that transversal is. And if you notice, we have two spots for this transversal that we could draw in. We could draw a transversal in over top of XL, or we could draw it in on WX. Now, there's only one right answer that we can actually pick, and I'm going to do the wrong one first. This does not create the same picture that we have up top, because while you could say, yeah, that's alternate interior angles, if you notice this top angle, it has some part that is inside and some part that is outside. That is a big no-no. We don't want to do that. So there is a little bit of a decision that we need to make when we're looking at a few of these examples. So again, here and there, our transversal is the one that goes up and down. It's the stacked part of it. So now, two angles that make our picture look like one of the above is actually dealing with the corresponding. So we have angle Y, X, Z, and angle X, W, L are congruent because of our cat theorem, corresponding angles theorem. Okay, so you have two options there and a few more pictures just to finish each one of these out. For number 3, the picture looks a lot bigger. There's a lot more involved in this picture. And as we're going through, again, it's really important to figure out the two triangles. We have triangle ABE. You can see where that triangle is on the picture, and you have triangle BCD. There's extra information in here. We don't care, we don't need anything in terms of the top triangle, AFE, and we don't need anything in terms of our triangle BED. We are now just looking at the two triangles that are left in that picture. And the information given to us is that BE is parallel to CD. So BE parallel to CD, and now you notice we have our stacked option. It was very similar to the last example that we had, where now we're choosing which transversal we want. The only one that would make an accurate picture is this particular line. So as we're looking at it, we have two angles. We know that one of the angles we're dealing with is angle ABE, and the other corresponding angle is our BCD. And again, we have our cat, or our corresponding angles theorem. Number 4, okay, you'll notice again, or at least hopefully you notice, that you have yet another stacked option. Usually that's a dead giveaway that we may have some type of corresponding angles in here. Well, let's see what the given information tells us. We have AL in this case, AL parallel to DN. Those lines are never going to touch one another. So which line would we have for our transversal? Our transversal would be EA. And now there are no alternate interior angles for angles that are inside of our triangle. So we're dealing with that particular angle, our angle E. D has to go in the middle. It's the most important letter of the three. Okay, and it's EDN. Our other angle on the bottom is going to be our DAL. And this is our corresponding angles. If you want to write out corresponding angles, that's fine. You want to write out cat, that is fine as well. Okay. Now, last but not least, for number 5, we have two triangles again, ABC and triangle EDC. This looks like the same information because we have AB that is parallel to our DE. And you're probably thinking, well, what's different right now? There is absolutely nothing different. But now we're choosing our transversal. That transversal has a couple options here. If we use our transversal BD, notice that we're going to have alternate interior angles. We're going to have that particular angle, which happens to be our A, B, C, has an alternate interior inside with our C, D, E. That is one set that works. And we know that that is our alternate interior angle theorem. But notice how there's two lines here. We could have chosen a different transversal and still had another option that works. So we have that and that side, AB and side D, that are still parallel. But if I choose the other transversal, now the other line that's in this triangle, we have angle BAC, BAC, that is still has an alternate interior angle with it. We have this angle would be our D, E, C. Sorry, I couldn't see the letter there that I was dealing with. So in this type of a proof, you would have an option, and your proof may look different than the partner that you are working with and what they decided to use for their proof. Your homework, your goal for tonight is to finish 1 through 4 on the parallel proofs worksheet. Have a great rest of your day, and I will see you tomorrow. Happy geometry!